Alright, here's example 4 with evaluating inverse trig functions. So in this video we're going to talk about the inverse cotangent function. And again, just like with the first 3 examples so far, it's really just a matter of knowing the unit circle and knowing the range of this function here. So what's the range of the inverse cotangent function? Well, the range of the inverse cotangent function is, the way we defined it, it's 0 to pi. And again, we did mention a few videos ago briefly that it is possible to define this using a different range. But we don't want to get caught up in that. So let's just ignore that, and we'll say the way we defined it was from 0 to pi like this, not including the endpoints, so not including 0, not including pi, because cotangent has vertical asymptotes there. So the inverse cotangent actually has horizontal asymptotes there. Okay? So anyway, now we're just going to approach it the same way we've been doing the first 3 examples. And what we're going to do is we're going to ask ourselves which theta in the range of the inverse trig function has cotangent of theta equal to 1 for part A. Okay. And again, just like we've been mentioning, there are infinitely many numbers, infinitely many angles theta whose cotangent is 1, but there's only one such theta inside of this interval here. And it's really just, again, just a matter of knowing the unit circle. And if we pull out a unit circle, we check it out, we'll see, okay, well, just remember that cotangent is cosine divided by sine. So we see that cotangent of pi over 4 is 1, and that's it. Cotangent of pi over 4 is 1, and pi over 4 is between 0 and pi, so we're good. That's our answer. So inverse cotangent of 1 is pi over 4. Because the cotangent of pi over 4 is 1, and pi over 4 is inside of this interval. Okay, so again, there are infinitely many numbers whose cotangent is 1, so pi over 4 is an example, 5 pi over 4 is another example, and 9 pi over 4 is another example, but there's only one such number whose cotangent is 1 and is also in this, the number is also in this interval, and that number is pi over 4. Okay. So again, just know the unit circle and know the range of the inverse trig function. Okay? So that's it for part A. Part B, we ask ourselves the exact same question, but now we're looking at negative root 3 instead. So which theta inside of the range of the inverse cotangent function has cotangent of theta equal to negative root 3? Okay, and again, it's really just a matter of knowing the unit circle. So remember, cotangent is cosine divided by sine. So if you check out a unit circle, you'll see, okay, well, first of all, they have to be between 0 and pi. So cotangent, basically what I'm doing is I'm looking for a theta whose cotangent is negative square root of 3. So I want a theta with a negative cotangent. Where is cotangent negative? Well, it's negative in the second quadrant, right? So here, 0 is right here, pi is right here. So our answer has to be in the first quadrant or in the second quadrant. Okay, so cotangent of theta is negative root 3. We're looking for this theta. Theta has to be between 0 and pi, so it's in the first quadrant or the second quadrant. Well, it's going to have to be in the second quadrant because cotangent of theta is negative root 3. That means cotangent of theta is a negative number, and cotangent we know is negative in the second quadrant. So whatever number we get, whatever theta we get, has to be somewhere in the second quadrant. Okay? So that's one clue, sort of. That's one clue to help us out. So then we can take a look at the unit circle and see, okay, cotangent of 5 pi over 6. Cotangent of 5 pi over 6 is negative square root of 3. Okay. So your unit circle might not be labeled with cotangents, but again, remember that cotangent is just cosine divided by sine. Or if you might have a unit circle and maybe a chart of values. You might not have all the cotangents memorized, which is fine. As long as you remember how to get them, remember that cotangent is cosine divided by sine. So that's really what you want to remember. So it's a matter of knowing the unit circle and knowing the range of the inverse trig function. And if necessary, just remember, definitely always remember that cotangent is cosine divided by sine. You'll always want to remember that for sure, this far along a trig especially. So do remember that, be careful about that and everything. Okay, so that's really pretty much it. Cotangent of 5 pi over 6 is negative root 3. So what that means is that our answer is 5 pi over 6. Okay, so inverse cotangent of negative root 3 is 5 pi over 6 because the cotangent of 5 pi over 6 is negative root 3 and 5 pi over 6 is inside of this interval. And again, there are infinitely many numbers whose cotangent is negative root 3, but the only one in this interval is 5 pi over 6. Okay. Now, what about the inverse cotangent of 0? So we just ask ourselves the exact same question. Which theta in this interval from 0 to pi has cotangent of theta equal to 0? Okay, because we want the inverse cotangent of 0, so we want to find a theta whose cotangent is 0. Okay? We want to find a theta whose cotangent is 0. That's how we do that here. So again, just look at the unit circle. Remember that cotangent is cosine divided by sine. And when you remember those two things, check out the unit circle and remember that cotangent is cosine divided by sine. And you'll see that cotangent of pi over 2 is 0. Because cosine of pi over 2 is 0, sine of pi over 2 is 1. So this is really 0 divided by 1. Okay, 0 divided by 1. So in other words, cotangent of pi over 2 is 0. So that's our answer. So we see there's really not a whole lot of work to be shown here. It's really just a matter of knowing the unit circle and remembering to use the correct range. Okay, so the inverse cotangent of 0 is pi over 2 because cotangent of pi over 2 is 0 and pi over 2 is inside of this interval. Okay? So again, we do want to point out that there are infinitely many numbers whose cotangent is 0, but there's only one that's also in this interval. So cotangent of 3 pi over 2, negative pi over 2, 5 pi over 2, and so on and so forth. All those numbers have cotangent that are equal to 0, but those are not inside of this interval. Only pi over 2 satisfies this and being inside of this interval. Okay, now that's really it for example 4 with inverse cotangent here. So I do want to point out real quick that just like with example 3, there's no part D here. Remember in examples 1 and 2 we had a part D where the answer was no solution, so or does not exist, but we couldn't do that with inverse tangent, and we also can't do that with inverse cotangent because the domain is all real numbers. Okay, so the domain of inverse cotangent is all real numbers. So in other words, you can take the inverse cotangent of anything you want, any real number that you want. You can take the inverse cotangent, everything's going to be fine. So when you do the inverse cotangent, you're never going to get does not exist or no solution, because you can take the inverse cotangent of anything you want. Okay, so that's it for example 4, evaluating inverse trig functions, and this has been the inverse cotangent function.